Hi folks, this is 34F from page 483. So they want us to find the Cartesian equation of a plane which is perpendicular to this given plane and that contains this line here. Okay, so let's start. So at some point I'm going to have to find a normal vector. Okay, and let's see what information they give me. Well, they give me that the plane is perpendicular to this other plane. Okay, so say this is the second plane. Well, what information do I get out of this equation? I get a normal vector. And I realize that because these two planes are perpendicular, a normal vector to this vertical plane is just going to be a direction vector for the plane I'm looking for. Okay, so from this plane here, I can get a first direction vector, which would just be 1, -2, 1. Okay, so second piece of information that it contains this line. So again, if this line is on the plane, then it means its direction vector can be another direction vector for the plane. Okay, now of course the only way I can use this as a second direction vector is if it's not parallel to the first, and clearly these two are not parallel. So there we go, here we have a second direction vector. And so now what we can do is find the cross product of the direction vectors to determine a normal vector. Okay, so let's do that here. So find the so here we have -4 minus 1 is -5, and then here we have 3 minus 2 is 1, and here we have 1 plus 6 is 7. Okay, but since I'd prefer having a positive leading coefficient, what I'll choose as my normal vector is to just multiply this by -1 and use 5, -1, -7. Okay, and now that I have the normal vector and I've got a point on this plane, because I know 2, -1, -1 is on the line, which is on the plane, so the point is on the plane, I can just find the d value here. So my a value is 5 times the x component of the point, 2, okay, minus 1 times -1, okay, and then minus 7 times -1, and plus d is equal to 0. So I can solve for d. So here we have 10 plus 1 is 11, plus 7 is 18. So bring that to the other side. D is equal to -18. And so the equation of my plane is 5x minus y minus 7z minus 18 equals 0. Okay? So just to recap, we needed to find direction vectors that would eventually lead us to a normal vector. One of them was pretty simple because it was just the same direction vector as the line on the plane. This one here, just had to do a bit of thinking that if these two planes were perpendicular, then the normal vector on one can be used as a direction vector on the other. Okay, that's it for this one.